Precipitation or rainfall is the major source of water and determine the availability of water resources at temporal and spatial scale. Hence, let's start with supply side uncertainties. First, supply side issue is variable monsoon rains and uneven distribution and seasonality of rainfall. India's long-term average annual rainfall is the highest compared with other countries of comparable size. Several meteorological processes over the Indian Ocean and on the land determine the variability on several timescales. Besides, the geographic spread of India obscure the progress of monsoon and quantity of rainfall. Rainfall over India shows a wide range of spatial variation due to orographic influence and preferential occurrence of the rain-bearing systems in certain regions. The Indian monsoon is highly unpredictable as 4 out of every 10 monsoon seasons are categorized as abnormal. Based on long-term average, 19% of the years during the period starting from 1901 to 2019 were drought years. This periodicity in rainfall result in water scarcity in many parts of the country during the non-monsoon period. Considering the importance of monsoon rainfall for growth of agriculture sector and socio-economic welfare of country, occurrence and variability in rainfall is discussed in detail in a separate module. Another supply related issue is linked to skewed distribution of water resources, temporal and spatial variability in surface runoff and groundwater regime. It results in a regional mismatch between water availability and water demand. The water resources potential or annual water availability of a country in terms of natural flow in river is about 1869 BCM. India is blessed with several large and hundreds of coastal rivers. The basin scale water balance suggests that the distribution of surface water resources mimic the rainfall patterns. However, this availability is not uniform and is highly uneven both in space and time. This course follows the watershed approach to describe, compare and discuss the relative availability, usage and water resource management. The Himalayan rivers are transnational rivers, hence the gauge and discharge data of these rivers comes under classified category and is not available for scientific use. In contrast, the peninsular rivers drain entirely within the political boundaries of India and the gauge and discharge data of these rivers are publicly available. Therefore, the module on surface water resources provides greater detail of water balance and role of environmental variables on peninsular rivers, their discharge characteristics. That module also provides exclusive data on the Indian coastal rivers. In contrast to visible distribution and quantifiable use of surface water resources, the occurrence of groundwater resources and their uses are much more complicated. Rainfall patterns and catchment characteristics determine the aquifer yields and recharge rates, whereas local, demographic and agricultural needs decide the extent of groundwater development and sustainable use of the groundwater resources. Therefore, the module on groundwater resources provide an in-depth analysis of various aquifer types, the occurrence and use of groundwater resources and the current state of groundwater development in India. Climate change and its impact on rainfall patterns and water resource availability is being considered as one of the major threats to water security of India and its population. Studies have shown that change in rainfall pattern in terms of intensity and overall rainfall may severely impact India's water resource availability. Despite implication of climate change on water resources, efforts so far have been limited to investigate change in surface water availability at regional or river basin scale. You will learn more about the regional disparity in rainfall and impact of climate change on the water resources in the module on climate change and its impact on water resources and societal intervention later in this course. Now, let's focus on issues arising out of the growing demand of water in India. Here, we will first learn about the irrigation needs. We have already learned that India as a country holds the largest chunk of cultivable land. Despite the large-scale expansion of irrigation facilities, perennial irrigation facility could be extended to only 1/3 of the crop area in India. Remaining 2/3 of the cultivable area is under rain-fed irrigation, mostly depending on unreliable, uncertain and irregular monsoon rains. Based on the rainfall patterns, irrigation facility, soil type and type of crop, the arable land is used to grow 1, 2 or 3 crops in a year. Due to tropical climate, the evaporation rates are very high in India and crops require a regular supply of water. The Indian agriculture sector is the largest consumer of water. Due to absence of adequate irrigation facilities, farmers turn to groundwater, resulting in an alarming depletion of groundwater resources. Majority of Indian farmers still use the conventional flood method of irrigation. This poor water use efficiency further complicate the groundwater resource availability. The Green Revolution has helped India to become self-sufficient in food grain production. The Green Revolution transformed the traditional farming with mixed crop pattern to high yielding wheat, rice, sugarcane and cotton at the cost of coarse cereal and pulses. The Green Revolution introduced the water intensive high yield variety seeds which require alternating amount of water supply during its growth, particularly during dry season. So farmers cannot remain dependent on monsoon and these crops need to be irrigated regularly. States of Maharashtra, Uttar Pradesh, Punjab are famous for showing water guzzling crops like sugarcane and paddy and use lakhs of liters of irrigation water per hectare per year. There are two main reasons for this. First, power subsidies for agriculture have played a determining role in India's decline in water level. Second, it has been observed that among the 23 crops having minimum support price or MSP, the most effective price support is for sugarcane, rice and wheat which require more water. It creates highly skewed incentive structure in favor of these water intensive crops. If the cropping pattern and water uses are not reset, sustained production of thirsty crops will further deplete scarce water resources. We will discuss all these aspects in greater detail in the module on irrigation and related aspects in India. India is currently second most populated country and also one of the most densely populated region, and we have learned those numbers in first part of this lecture. But how does it relate with the water availability? In this section, we will learn about it. At the household level, potable water is required for drinking, cooking, cleaning, personal hygiene and sanitation. Under normal conditions, the recommended domestic per capita per day water consumption is in India should be around 135 liters. However, daily water consumption for an average town dweller in India is lower than this standard requirement. Now, you might have certain questions such as how much water is actually required for a happy and healthy life and how does it affects the quality of life. What exactly we mean by water scarcity and water stress? Do we have any criteria to or formula to calculate it? Water scarcity, which can broadly be understood as the lack of access to adequate quantities of water for human and environmental use, is increasingly being recognized in many countries including India as a serious and growing concern. As a result, the term water scarcity is regularly used by different sections of society and media. One of the most commonly used measure of water scarcity is the Falkenmark indicator or water stress index. It relates the total freshwater resources with the total population in a country or region and indicates the pressure that population puts on water resources, including the need for natural ecosystems. This method defines water scarcity in terms of total water resource that are available to a population of a region, and measuring scarcity as the amount of renewable fresh water that is available for each person each year. If the amount of renewable water in a country is below 1700 cubic meter per person per year, that country is said to be experiencing water stress. Below 1000 cubic meter, it is said to be experiencing water scarcity, and below 500 cubic meter, absolute water scarcity. A region is said to be under water stress when the water demand exceeds the available volume or when poor quality restricts the use. Let us try to see where we as a country stand. Due to multifold increase of population in India, per capita water availability reduced from over 5400 cubic meter in 1951 to 1900 cubic meter by 2001 and 1500 cubic meter in 2017. It is expected to reduce further to 1340 cubic meter by 2025 and 1140 cubic meter by 2050. It implies that we already have a water stressed country. India stands at number 13 among the world's 17 extremely water stressed countries. If we go down further deep, due to regional disparity in water resource availability and water quality issues, approximately 820 million people living in 12 river basins across the nations are already facing water scarcity situation. Beside, a sizable part of India, particularly northwestern states, falls under extremely high water stress level. Extremely high water stress level means that an average 80% of the available water in a region is consumed every year. With this population growth and improved purchasing capacity, the country's annual food requirement by 2050 will exceed 250 million tons. It will be around 375 million tons if the requirement for feeding livestock is added. The surge in demand for various water intensive crops will multiply our current agriculture consumption of water. For the year 1990, water requirement for different purposes in India was about 500 BCM. In 2020, the requirement was about 1100 BCM and projected to be increased to 1200 BCM in 2025 and 1450 BCM in 2050. The water requirement for livestock will also rise proportionally. Decadal change in water requirement suggests that in the last 30 years, water requirement in India for various purposes doubled. This rapid population growth and unplanned development has added pressure on available natural resources and infrastructure, including water resources. These issues are more visible across the cities. Indian cities face several challenges of upgrading water supply and sanitation infrastructure, ensuring a regular and adequate supply of improvised water, So urbanization has added another dimension to water stress. Factors such as cities, size, presence of industries, climatic conditions, economic status and habits of residents and the quality and cost of water supply governs per capita demand, while factors such as pressure on the municipal supply system, efficiency of water supply administration and policy of metering and charging methods determine the supply side. There are challenges in the urban water management include demand and supply gaps, further water needs of urban India, issues with municipal infrastructure, depleting groundwater resources, release of urban sewage to surface water bodies and fate of treated wastewater, water quality deterioration and encroachment of urban water bodies like rivers and lakes, impact of climate change in form of floods and droughts. These issues are described in detail in the module on India's urban water crisis and urban water supply and sanitation management and module on water pollution related aspects.